what is an oracle? Maybe you have heard the term before. This is something we have actually so far left out of our stablecoin design, but it's a critically important part. We just assumed the price of the US dollar is available in our contract. But how does it actually get there? There's no way to get this data in an easy way for smart contracts. But this is exactly what oracles do. Oracles are nothing more than some form of bringing off-chain data onto a blockchain. Think of an external API call or the weather forecast for tomorrow. You can't have Ethereum nodes retrieve this data directly because it has to be deterministic. Just imagine one node requesting an API to ask if it's going to rain tomorrow. The answer right now is no, but only 5 minutes later the next node validates the transaction, requests the weather API, and now it says yes, it will rain tomorrow. So that's not going to work. A transaction has to be able to be validated by anyone at any time with the same result. So now think of a contract that stores the weather forecast for tomorrow. In the simplest form, the design would be something like a smart contract with functions to read and write the forecast data, and a server fetching the forecast from an API and regularly updating the smart contract. That's really all we need for a simple oracle. By sending a transaction to our smart contract with the forecast data, it becomes available on-chain for other contracts. But only one server that updates this? Maybe you can see the problem. Solving this and actually having a decentralized, trustworthy oracle is a very difficult task. So you don't only have one server that is updating data that you have to trust. I mean, then we might as well not have decentralization and smart contracts to begin with. One of the most known providers for this is Chainlink. They have their own network with nodes that are providing data in a somewhat decentralized way. We won't have time to get into its details here, but whatever service you use, you should always be aware of where the data comes from, how easy it would be to manipulate it, and consider this when you are actually dealing with the data inside your own contract. Let's just quickly implement an oracle that we can use for our stablecoin, but of course we will just be using a centralized oracle, which is actually pretty easy to implement. So let's just create a new oracle.sol and create the structure here. Let's call it contract oracle. And now we need to have an owner function here. And this owner will be the one that's actually allowed to update the prices of the oracle. And then we also need a variable to actually store the price. So let's call it price. And then in the constructor, we just set the owner as the person who was deploying the contract. So that's owner equals msg.sender. And then we just need two functions basically. One is to read the price. So let's just get price external view, and it returns uint 256. And we can return the price. And then we need also a function to actually update the price. So let's call it set price and new price and external. And now, of course, not anyone should be able to actually update this price, only the owner. So let's check that the sender here is actually the owner. And then we can update the price. So price equals new price. And this is it. This is already a very simple oracle function that we can then use in our stablecoin. So now in our stablecoin contract, let's use the oracle, which is pretty simple. We just import it. From oracle.sol. And now we pass the address of the oracle upon deployment. So basically, if someone wants to deploy it, he first has to deploy the oracle and then pass the address of the oracle to the stablecoin when he deploys the stablecoin. So oracle, and then the oracle will be what we're passing it here. And we'll have to define it, of course, in the state here. So that's the oracle type, public oracle. And that's the correct name. And now let's use the oracle instead of this weird ETH and USD price, which we hard-coded before. So we can delete this. And instead here we call oracle.getPrice. And same here, oracle.getPrice. So it will automatically call the oracle and get the latest price here.